Well, good morning. It's time to start the next chapter on balancing chemical reactions. So in doing chemical reactions, the whole idea in this one is we're going to take elements and compounds, but we're going to take them and basically we're going to put them together. We're going to tear them apart. We're going to exchange them. We're going to do all that kind of stuff. We're going to get an idea as to how these things go together, how they do this, and what's the ratio that they go together. That's really what chemical reactions are all about, is to have an understanding of what chemicals out there do, right? I will tell you one thing that a lot of people put down as an answer that is not the answer is on this whole idea of doing this chemical reaction stuff is so that the chemical reactions don't blow up or anything like that. No, the reactions are going to do what they're going to do. All this does is this helps us understand or get an understanding of what happens when you take chemicals and put them together. What is formed after you put two chemicals together, or do they actually even form anything? So in doing this, we're going to start off with a really simple equation to start with, and that is we're going to take H2 plus O2, and we're going to form H2O with this. So this is the formation of water. It's taking hydrogen gas, we're going to combine it, that's what the plus means, we're going to put it together, we're going to combine that with O2. And then this arrow here means yields. It means we're going to form the stuff that's on this side, which there is a term for these things, which was in your notes. These things on this side, these things are called reactants. Those are the things that react, and then they produce the products. The products are over here, and there might be one product like this one. There might be two, there might be three. There might be all sorts of multiple different products. But in this one, there's only one product, and that's water. All right, so now this will do it all by itself. You put hydrogen and oxygen inside of a balloon and light a match, it'll go boom, and blows up, right? And it makes water. It's going to do it on its own. This just helps us understand how much of each thing has to go together. And there is a law out there, and this is why we balance chemical reactions, and that is the law of conservation of mass. And that says that matter cannot be created, nor can it be destroyed. All we can simply do is rearrange it. So that means the reactants on this side, the stuff that we have on this side, we have to have exactly the same amount on this side. I can't create it, I can't destroy it. All I can simply do is rearrange it. Kind of like a deck of cards. And a deck of cards has 52 cards in it. But when I shuffle it up, do I still have 52 cards? I should, unless I dropped one. But I should have all 52 cards in there. Are they in the same order? No, probably not. I can't imagine they'd be in the same order unless you organized them, right? So that's the idea in this. We got the 52 cards on this side, then I shuffle them. That's what I do here, shuffle them, and then I end up with the same 52 cards on the other side, but in a different order, right? And the way in which I like to teach this to get you to do this is we're going to take each one of these compounds or molecules, and we're going to go, what do I have in this first thing? Well, I got two H's, right? And then that's being combined with whatever is here between the plus and the arrow, and what's there is a two O's. Then we got the arrow. The arrow is my equal sign. So it's got to be equal to what's on the other side. Well, here's one thing. There's no plus separating it, so it's all one circle. So this happens to be two H's and an O. So now what we have to do is we have to have the same number of each element on both sides. And I hope that you can see this already and go, well, the O's don't even out on each side. Because currently right now we got 1, 2 H's, and those are equal to 1, 2 H's. But then we got 1, 2 O's, that doesn't equal the one over here. What would be nice to do is let's just throw another 2 on here. There we go, that fixes it. Now I got 2 O's, but I can't do that. Because by doing that red 2 that's up there, that just turned the water into a poisonous substance called hydrogen peroxide. And that's not what is produced when these two guys go together in this form. So I can't change these numbers down here. Right? They are what they are. So then maybe the other option is, well, maybe I just get an extra oxygen, right? No, can't do that either. What I can do is I can get another entire water. So now I have 2 waters. That gives me 1, 2 O's, 1, 2 O's. But now I just messed up my H's. I got 1, 2, 3, 4, and I got 1, 2. Oh, I can do this. I can make it so that I have 2 of these guys. Now I have 1, 2, 3, 4 H's, 1, 2, 3, 4 H's, 1, 2 O's, 1, 2 O's. Oh, now everything's even. So now what I'm going to do is I'm going to go back up here and go, well, this says I got 1, 2 of these guys. So I'm going to put a big 2 out in front of that saying I got 2 H2s. I got 1 circle of O2s. So remember in chemistry, we don't write ones. So we just leave that blank saying that there's 1 O2. And then over here, I got 1, 2 H2O, so I got 2 of this guy. So now this up here, that's my answer. This stuff down here, that was my work in order to get to the answer. This is not the answer. That just helps me get to it. So what does this tell me at the top? It says 2 molecules of hydrogen, or H2, will combine with 1 molecule of O2. That's going to form 2 molecules of water. That's what this balanced equation says. That's what it says happened inside of this balloon when I light a match and it goes boom and blows up. Right? It also means that basically if I was going to do this really, really well, I would want to put 2 parts hydrogen to 1 part oxygen, and then I would get it all to react. Right? And again, remember, according to the law of conservation of matter or mass, whatever I have on this side, I can't create it nor destroy it. All I can simply do is rearrange it when it gets over here. And that's what I hope you see in these red things down here. It was arranged this way, and it comes over here, it's arranged differently. It's just a shuffled up deck of cards. All right, let's do the second one that was in your notes. So the second one we've got is NaCl plus H2O again. And that's going to form Na2O plus HCl. See on the screen? Yep. Okay. I got a mosquito flying around. He's driving me nuts. But all right. So first thing we're going to do on this one is, and I will tell you that on the notes I couldn't make the circles, so what I used is a table. So you're going to see that the equation is written across the top of the table, and then what I have underneath is in boxes are the circles. So in the first box there, there's 1 Na and I got 1 Cl. And then I'm going to go, well, that's plus my 2 H's. And that's in the next box. Then there's a blank box to mean the equals box. All right. Then we get to Na and Na, because there's 2 of them, plus 1 O, plus we've got an H and a Cl. Now there's a little rule of thumb that I like to teach on this, and that is start with the first element that's all the way over to the left, work your way over to the equal sign, but leave hydrogen and oxygen until last, right? Don't try and do the hydrogen and oxygen first, because what you'll find in a lot of these ones is those will be very frustrating trying to do. But if you do all the other ones, the hydrogen and oxygen commonly just falls into place, right? So first element's Na. I got 1 Na on this side. I got 1, 2 on that side. Oh, so I need some more of this. So I'm going to make another whole circle here and make this all over again. So I got 2 Nas. Then I go to Cl's. I got 1, 2 Cl's. Over here I only got 1. So I need another one of this guy. So there's my 1, 2 Cl's, 1, 2 Cl's. All right, now all that's left now is hydrogen and oxygen. So we'll go to that hydrogen next. 1, 2 hydrogens. 1, 2 hydrogen. Oh, look at that. That circle we did before helped me out with the hydrogens. And then I got 1 oxygen, 1 oxygen. So that's my answer. So now I have to go back and don't forget to put it in the circles. I'm see that. Count the circles. So I got 1, 2. So I have 2 of this guy. I got 1 of this guy. Leave it blank. 1 of this guy. Leave it blank. 1, 2 of this guy. Put a 2 there. So 2 molecules of table salt, NaCl, will combine with 1 molecule of water, and that's going to form 1 Na2O, or sodium oxide, plus 2 molecules of hydrochloric acid. Right? If we actually get this to react together, not just dissolve it in water. This is not dissolving water. This is a chemical reaction of salt and water. All right, I think I got another one to show you. Flip the page. Yep, I got 2 more. All right, next one. Ooh, this one looks really, really bad, but the whole idea is to do it step by step, and it's not that hard. All right, there's our equation. So we'll start off with the first one that's right here. Inside that circle, we've got 2 ALs. Then we got in parentheses here, we got an S and 4 O's. But we have that 3 times. So I got an S and 4 O's, and an S and 4 O's. All right. So notice the way in which I did that is that, where was that mosquito? I think I got him. I hope so. But, so notice I did S and 4 O's, like what was in parentheses, and then did it 3 times. 1, 2, 3. The common mistake that people do on this is they make S and 4 O's, and then they just do 4 O's 3 times, or they forget to do that S 3 times. All right, but it's everything that's in that parenthesis is 3 times. All right. Then we go plus my next thing, which happens to be an mg, and then I got 2 CLs. And my arrow, that's my equal sign. Then we come over to, I got an AL, and I got 3 CLs. And then I have plus, I got an mg, and an S, and 4 O's. Okay, so again, remember my little rule of thumb, start with the first element all the way over to the left, work your way over to the arrow, leave hydrogen and oxygen till last. Now notice in this one, there's no hydrogen. That's okay, just that's my standard phrase is leave hydrogen and oxygen till last if it's present, okay? So we start off 1, 2 ALs. Oh, I got 1 AL, so I need some more of this guy. So we're gonna go 1 AL, and I need to repeat everything that's in the circle. So I get my ALs even. 1, 2, 1, 2. Then I got S's. 1, 2, 3. On this side, I only got 1. So I need some more of this guy. And I make everything that's in the circle again. There's 2 S's. There's my 3 S's. That evens that out. Now skip the O's, go to the MGs. I got 1 MG and I got 1, 2, 3 MGs. Ooh, I need some more of this guy. MgCl and an MgCl. That gives me 1, 2, 3. 1, 2, 3. CLs. I got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. All that's left was my O's. To double check those. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my answer. So now I go through and put my numbers in. Well, I got 1 circle of this, leave it blank. 1, 2, 3, so 3 of this guy. 1, 2, 2 of him. And 1, 2, 3, 3 of that guy. And that would be my answer for that one. All right, I'm gonna stop there. We're gonna go to part number 2 so I don't run out of time on my next one, so I'm getting really close. So we'll see you in a minute.